Imagine if you had a car that doesn't need an engine or spark plugs, has no exhaust pipe, and is so quiet when starting that it feels like it's not even on. But the moment you step on the accelerator, it might bolt forward faster than a sports car. This sounds like something out of a sci-fi movie, but this is the electric vehicle we see everywhere today. Many people are curious. Since there's no gasoline burning and exploding inside, how does this multi-ton steel monster actually got the power to move? Today, let's decode the secrets of electric vehicles and see how they perform this magic. Part 1. The massive power bank beneath the chassis. First, let's look at the power source. Traditional cars need gasoline, while EVs need to be charged. If you flip an EV over, you'll find its chassis is covered with battery packs. This is essentially a giant mobile power bank. The batteries in our phones are lithium batteries, and so are those in EVs. It's just that thousands of them are combined together. This massive battery stores a huge amount of electrical energy. But here's the question: electricity is just energy. It's not like gasoline that flows into an engine to push pistons. To turn electricity into motion, we need the next key player. Part 2. Electromagnetic induction, making the motor spin. That player is the motor, which is the heart of an EV. Do you remember the right-hand rule from physics class? Simply put, when an electric current passes through a wire, a magnetic field is generated around it. EVs use this principle of electricity generating magnetism. Inside the motor, there are countless coils and magnets. When electricity from the battery flows into the motor, the coils become powerful electromagnets, based on the principle that opposite poles attract and repel like poles. The rotor inside the motor is pushed by this strong magnetic force, pushing it along, spinning frantically and continuously. This is why electric vehicles don't need ignition. They aren't powered by explosions, but by magnetic forces pushing against each other. And the most amazing thing about a motor is, it doesn't need to warm up. As soon as power is on, the magnetic force explodes instantly. This is why the pushback feels when an EV starts is so much stronger than that of a combustion engine car. Part 3. The smart brain electronic control system. With a battery and a motor, we still need a brain to control the speed. If you connected the battery directly to the motor, the car would bolt at full speed like crazy the moment it starts. That would be too dangerous. So there is a neural center in between, called the Power Control Unit (PCU). When you step on the accelerator pedal, you are actually sending a signal to the computer. The deeper you press, the brain commands the battery to release more current to the motor, making the magnetic force stronger and the car go faster. The coolest part is that EVs have a special trick. When you lift off the accelerator or hit the brakes, the motor reverses and becomes a generator. The kinetic energy of the car moving forward is captured by the motor and turned back into electrical energy and charged back into the battery. This is why EVs in stop-and-go city traffic are actually more energy efficient than you'd think. Conclusion. To summarize, an EV uses a battery as its energy reservoir. The electronic control system acts as the commanding brain, and finally uses electromagnetic force from the motor to drive the tires. There is no combustion, so there is no smoke, and no deafening engine noise. This isn't just a change of fuel to make transportation cleaner and more efficient. Next time you see a silent Tesla or electric bus gliding by, remember that countless electrons are dancing in the coils, using magnetic force to carry us forward.